We have to answer the following question. Given that 1 plus p and 1 plus q are the roots of the quadratic equation 2x squared minus 5x plus k equal to 0, form a quadratic equation in terms of k whose roots are 1 plus p squared and 1 plus q squared. We take solution. First thing, we are going to start by comparing the given quadratic equation 2x squared minus 5x plus k equal to 0 with the general form of a quadratic equation ax squared plus bx plus c equal to 0. If we compare, a is equal to the coefficient of x squared, which is 2, comma, b is equal to the coefficient of x, which is negative 5, and c is equal to the constant term, which is k. Now we can find the sum of roots, the product of roots of this our equation. We have been given that the roots are 1 plus p and 1 plus q. First, we are going to start by finding the sum of roots. The sum of roots 1 plus p plus 1 plus q, and this is simply equal to 1 plus p plus 1 plus q, which is equal to 1 plus 1 gives us 2 plus p plus q. We know the sum of roots is equal to negative p over a. So this will give us 2 plus p plus q to be equal to negative b. We put the negative sign. The value of b is negative 5. Then we divide by the value of a, which is 2. So this will give us 2 plus p plus q is equal to 5 over 2. Then we need to find p plus q. P plus q will be equal to 5 over 2 minus 2 over 1. We are going to transfer this 2 to the right hand side, which gives us negative 2. Then p plus q will simply be equal to the LCM of 2 and 1 is 2. 2 divided by 2 gives us 1. 1 times 5 is 5 minus 2 divided by 1 gives 2. 2 times 2, 4. Then p plus q will simply be equal to 5 minus 1, which is 5 minus 4, which is 1 over 2. So this will give us p plus q to be equal to a half. We are going to call this one equation 1. The next thing, we need to find the product of roots. The product of roots, we are going to take 1 plus p times 1 plus q, and this will simply be equal to 1 times 1 gives us 1 plus 1 times q gives q plus p times 1 gives p plus p times q gives pq, and this will simply be equal to 1 plus q plus p is the same as p plus q. Addition is commutative. Write this as p plus q in brackets plus p times q. So this will give us 1 plus p plus q gives us a half plus pq. This will be equal to 1 plus a half. We take 1 plus a half. 1 can be written as 1 over 1. And this is simply the same as 2 over 2. 2 over 2 gives 1 plus a half, which is simply equal to a half a common denominator. So we can add their numerators. 2 plus 1 gives 3 on 2. So this will give us 3 over 2 plus p times q. We know the product of roots of the quadratic equation is equal to C over A. We're going to divide C by A. Then, if you take 3 on 2 plus P times Q, which is equal to C. C is equal to K divided by A, which is 2. Then, P times Q will equal to K on 2 minus 3 over 2. Then, P times Q will be equal to, they have a common denominator which is 2, so you can subtract the numerators, then we maintain the common denominator, K minus 3 on 2. We call this one equation 2. So we have P plus Q to be equal to a half. We have P times Q to be equal to K minus 3 over 2. Now we can proceed now to find the equation with roots 1 plus P squared and 1 plus Q squared. Before we proceed, we need the expansion of P plus Q all this squared. We know this is the same as P plus Q times P plus Q. And this will be equal to P times P gives P squared plus P times Q gives PQ plus Q times P gives QP, which is the same as PQ plus Q times Q, which gives us Q squared. This is the same as P squared plus PQ plus PQ gives 2PQ plus Q squared. Now we are going to proceed to find P squared plus Q squared. If we make P squared plus Q squared a subject of formula, we have this P plus Q, all this squared is equal to P squared plus Q squared plus 2PQ. Then, if we make P squared plus Q squared a subject of formula, it will simply be equal to P plus Q, all this squared, minus, when we transfer 2PQ to the left, it becomes negative, minus 2PQ. Then, P squared plus Q squared will be equal to P plus Q is equal to a half. We're going to replace it with a half, so this will give us a half squared minus 2 times PQ is equal to K minus 3 on 2. This is what we are going to obtain. And this will give us P squared plus Q squared to be equal to a half squared. 1 squared gives us 1 all over 2 squared gives us 4 minus 2 here can be written as 2 over 1. 2 times K minus 3 all over 2, like this. And we can further simplify this. 2 go here 1, 2 go here 1. Then this will give us P squared plus Q squared to be equal to 1/4 minus K minus 3, like this, which is the same as saying P squared plus Q squared is equal to 1/4. We are going to expand this. Negative 1 times K gives us negative K. Negative 1 times negative 3 gives us plus 3, which can be written as 3 over 1. P squared plus Q squared will simply be equal to, if we take 1/4 plus 3 over 1, the LCM of the denominators is 4. 4 divided by 4 gives 1 times 1, 1, plus 4 divided by 1 gives 4 times 3, 12. And this will simply be equal to 13 over 4. So this will be equal to 13 over 4 minus K, like this. So this is the value of P squared plus Q squared. Now we can proceed to find the equation with roots 1 plus p squared and 1 plus q squared. So the first thing we need is the sum of new roots. The sum of new roots. We are going to take 1 plus p squared plus 1 plus q squared. And this will simply be equal to 1 plus 1 gives us 2 plus p squared plus q squared. And this will simply be equal to 2 plus p squared plus q squared gives us 13 on 4 minus k. 2 here can be written as 2 over 1. Next step, we are going to find the LCM of the denominators of these two fractions. The LCM of 1 and 4 is 4. 4 divided by 1 gives 4 times 2, 8 plus 4 divided by 4 gives 1 times 13. Gives us 13 minus k. And this is simply equal to 8 plus 13 gives us 21 on 4 minus k. So this is for the sum of new roots. The next thing, we need the product of new roots. And we denote the product of new roots as p n r. We denote the sum of new roots as n r. The product of new roots, we are simply going to multiply the new roots. We take 1 plus p squared times 1 plus q squared. And this will be equal to 1 times 1 gives 1 plus 1 times q squared gives q squared plus p squared times 1 gives p squared plus p squared times q squared gives p squared q squared. This will simply be equal to 1 plus q squared plus p squared is the same as p squared plus q squared. Remember, addition is commutative. Plus p squared times q squared is the same as pq, all this squared. This will simply be equal to 1 plus p squared plus q squared is equal to 13 over 4 minus k plus p times q, we know it is a half. So this will give us a half, all this squared. This will simply be equal to 1, which can be written as 1 over 1 plus 13 over 4 plus a half squared, which is 1/4 minus k. This will be equal to, we are going to find the LCM of the denominators of these three fractions. The LCM is simply 4. Bring down minus k. 4 divided by 1 gives 4 times 1, 4 plus 4 divided by 4, 1 times 13, 13 plus 4 divided by 4 gives 1 times 1, 1. This will be equal to 4 plus 13 gives us 17. 17 plus 1 gives us 18 over 4 minus k. So this is what we have for the product of new roots. Now we know the new equation. The new equation is given by new equation is given by, we are going to take x squared minus, take the sum of new roots times x plus the product of new roots. This will be equal to 0. That is x squared minus the sum of new roots. The sum of new roots is 21 over 4 minus k multiplied by x plus the product of new roots, which is 18 all over 4 minus k. We equate this to 0. Now at this level, we can decide to multiply both sides by 4 so as to eliminate this 4 at the denominator. Multiply both sides by 4. This will give us 4x squared minus 4 times 21 over 4 minus k times x plus 4 times 18 all over 4 minus k is equal to 0. This will give us 4x squared minus, put the negative sign, we take 21 over 4 times 4 gives 21. We are going to leave the negative sign out. Then we take 4 times negative k minus 4k, like this, times x plus 4 times 18 over 4. This will give us 18. 4 times negative k minus 4k is equal to 0, like this, which is the same as 4x squared. We can multiply all through by negative 1. This will give us negative 21. This will give us plus 4k. So we can write this as plus 4k minus 21 times x plus 18 minus 4k is equal to 0. This is the equation with roots 1 plus b squared and 1 plus q squared. Let's underline the equation. If in case you have any worries on this, you can watch the lessons I did on the relationship between roots and coefficients of a quadratic equation. There are numerous exercises I solved on this. Please, you like the video, you share and subscribe to this channel. Thank you very much for watching.